Now, not all arguments are equal. Some arguments work and some arguments don't work. What do we mean by works? An argument that works is called a valid argument. And this definition is a little bit different between deductive and inductive arguments, so we're going to treat them separately. In a valid deductive argument, if we know that the premises are true, then we know for sure that the conclusion is also true. There's no way to have all of the premises be true and the conclusion be false. What does that look like? How can we recognize that? And we're going to be learning more sophisticated ways of recognizing that throughout the rest of this unit. But here's the basic idea. Let's look at this valid argument here. We have two premises. All frogs are green, and Kermit is a frog. And then our conclusion is that Kermit must be green. Okay, so let's think about this. Why is it that the conclusion has to be true if all the premises are true? Well, let's imagine what it would look like if Kermit were not green. Suppose that Kermit were blue, right? Well, okay, so I've got Kermit, I'm looking at him, he's blue. Maybe he's not a frog. Maybe the second premise is not true, and then there's no problem, right? But if Kermit is a frog and he's blue, then are all frogs green? Well, no. If Kermit is a frog and he's blue, then Kermit would be a blue frog, right? So we can't have both of the premises true if the conclusion is false. That being the case, the argument is valid. And that's our basic plan of attack when we want to see, is an argument valid? We look for some situation that could exist, some state the universe could be in, where the conclusion is false, but both of the premises or all of the premises are true. And if we can't find that, if we're sure we can't find that, then the argument must be valid. Okay, here's what it looks like if the argument actually is not valid. I'm going to show you an invalid deductive argument now. So here's an argument. The premises are some dogs are gray, some dogs are big, and our conclusion is that then all dogs must be either big or gray. So again, we're going to try to imagine a situation in which the premises are true and the conclusion is false. Right, so let's think about 4 dogs, right? This list of dogs is consistent with all of the premises, right? So we have 2 big dogs on the list. Argo and Chewy are big gray dogs. Argo and Chewy are big dogs. Since we've got some big dogs, some dogs are big, our second premise is true. And we have some gray dogs, right? Argo and Bluto are gray dogs. So the first premise is true. We've got some gray dogs. But looking at our list of dogs, right? We've got a small brown dog here. Dino isn't gray, and he isn't big either. So our conclusion that all of the dogs have to be either big or gray, that's false. And that's what we were looking for to show that this argument is invalid. When we want to decide whether a deductive argument is valid, we try to find a way that the conclusion can be false if the premises are true.